Hi, welcome back to another Study With Me series. My name is Amy. I'm the head maths tutor for Pinnacle Coaching College. So what I've got for you today is introductory calculus. So how to do the basic stuff like differentiation with the very basic x to the power and some slightly more advanced rules, so like chain rule, product rule, quotient rule. The focus of this series is around revision and preparation for the prelim exam. So it's not really meant to be a learning module, so I don't go through all the basics assuming that you've already covered that at school. But if at any point it doesn't make sense, just leave a comment down below and I'm happy to respond to it as well. So the questions we'll look at today are all real past assessment questions from various schools. So you can see how it's examined in this particular area, the types of questions that come up. I do tend to pick harder questions. So if you want to push yourself, challenge yourself a little bit, give it a try before you look at the answer or see my explanation. Let's get straight into it. Okay, so let me move my face. All right, so before we get into it, right, let's look at what is on the reference sheet these days. And I think in the calculus department, they've included a little bit more formulas on the reference sheet. So you can see that, okay, apart from the very basic one, so the very basic one is y is x to the power of n. So when you differentiate that, you bring that power down and subtract the power by 1. So that's the most basic formula for differentiation. That's not in there because, to be honest, if you don't know that, you're pretty screwed for the exam. So all these are just the chain rule, product rule, quotient rule. That's all it is. So the first one is basically chain rule. So essentially, what you're really doing is bringing the power down. You see, that's in front. Subtract the power by 1 times the derivative of the function inside. Product rule, when we get up to it, you'll see how it applies. So u and v, so two different functions, basically is u v dash plus v u dash. That's probably the version you're going to try to remember. And if there's quotient rule, so this one here, top is u, bottom is v, so it's v u dash minus u v dash over v squared. Okay, I just realized the way they've done the product rule formula is not in sync with the quotient rule formula. So just be careful. The order matters when it comes to the quotient rule because it's a minus. Okay, this one is just a variation of the chain rule, which we're not going to use too much today because that's more relevant when we do rates of change. All right, so before we go in, I think just observing my own students, the formulas conceptually are very easy. What I find often is the problem is indices laws. So if you're not on top of your indices laws, I would say go find that chapter in your textbook and go and revise that first. So the main thing you need to look at is how to deal with negative indices. So for example, if you have 1 on x to the power 3, that's equivalent to x to the power of negative 3. Yeah, so that's one area which I find some students haven't fully wrapped their head around. You just have to practice that. And fractional indices. So for example, x to the power of a half is square root of x. X is equals to 3 on 2. Instead of writing it, well, this can be expressed as two ways. So square root of x cubed, or basically this is 1.5. Right? So 1.5 x. So sometimes we also write it as x root x. So a lot of that indices, manipulations, surds, that all comes up as well. Yeah, and I think when we go through them, you'll see what I mean. All right, so those are the basics. Hopefully it makes sense. All right, so I've sort of arrange the questions in a way. We'll start with the easiest, the stuff that's going to come up on first question as opposed to the last question in your upcoming exam. So let's start with the first one. Basically, with an expression like this, let me just write it all down so you can see and compare. So the derivative y dash. So you know that rule? You just apply it to every single term. Yeah? So bring the power down, subtract the power by 1. So 4x cubed. Bring the power down, subtract the power by 1. Now with 2x, the derivative is usually just the constant 2. You can think of it as bring the power down and it's x to the power of 0. And constant, derivative of a constant is always 0. So that's it. Now this is probably the only one I'm going to go into that level of detail around the basics. I'm hoping you already learned that at school, and this should be simple stuff. All right, so the second one. You need to simplify that first. Now, you can think of this as 2x cubed minus 9x to the power of minus 3 plus 8x times 1 on x to the power of 4. Yeah? Now, for those students who are not strong with indices, this is what I recommend you do. Now, you can't just differentiate like that, because to differentiate like the first part where you individually apply the rule, it has to be x to the power something and then plus or minus x to the power something and so on. Yeah, this one is not really like that. It's like that on the top, but you have an extra thing on the bottom, so that screws it all up. You need to fix that first. So what I recommend you do, depends on your preference, is change that in 1 on x to the power of 4 to x to the power of minus 4 and then expand it. So remember, in indices law, you add the indices. So when you multiply these two together, you add the indices together. Yeah, I'm just going to quickly write it all out and simplify. Yeah, that would be the cleanest way to go about this without getting into an algebra mess. So the derivative, you've got everything. You see how this is now like the previous one. X power, x power, x power. Okay, now you can differentiate. Bring the power down, subtract the power by 1. And then simplify. Now, I would also like you to get into a habit of converting negative indices back into positive indices. I mean, for this question, it's pretty much right on at this point, it's correct. But I think the students who have a good practice or habit of changing negative indices back to positive indices are just much more able to do the more advanced questions which require solving. So I recommend you just practice with, even if it's the easy stuff, right? Practice. You can never have enough practice in maths, right? Even if you know all the stuff, you're practicing for speed, accuracy, all of that stuff. All right, so that's it. Next one. So all of these, well, especially the first two, requires you to change it back into the indices form first before you attempt to differentiate this. So the first one, 5 on x is equivalent to 5 times 1 on x. I just want to clarify that. A lot of people bring the 5 in a strange place, so just be careful of that. So x to the power of minus 1. All right, so y dash is 5 times, bring the power down, subtract the power by 1. So that's minus 1 on x squared. Yeah, you know I like my positive indices. All right, that's your final answer. All right, so second one, there's more room here. I'm going to do it here. So this one, you need to change it to a single indices first. So basically x root x is basically x to the power of 1 times x to the power of half. Indices add when you multiply. And then we differentiate. Bring the power down, subtract the power by 1. So that's to the power of a half. It's correct, but let's change it back into root x. Yeah, that's nicer. finally, I might need to do this one on a new page, to be honest. Let me see. I want to try to squish this in. All right, so this one, it's two things multiplied together, and there is chain rule involved in the second one as well. So I'm going to carefully explain this. Okay, so product rule, because you got two things multiplied together. U dash, so you just differentiate that, so that's 2 times 2x, 4x. V dash, chain rule, bring the power down. Subtract the power by 1 times the derivative of the inside, which is minus 1. Right, so I'll just rearrange it a little bit. All right, so y dash is vu dash plus uv dash. All right, so vu dash is just these two times together. Uv dash, you just have to be careful with your signs because there's a negative here. All right, so notice that 3 minus x to the power 4 is the lowest common multiple, which I'm going to factorize. Now, I know a lot of students are like, but that's it, isn't it? That's the final answer. Yes, but if you need to solve it to anything, you still have to factorize anyway. So practice. Take the opportunity to practice. Yeah, don't just leave it just because you don't need to solve it. Use it as an opportunity to practice. It's a little bit of a pet peeve of mine when students say, oh, don't worry, I'll do it in the actual exam. And I know human behavior way too well to know that under stress, what makes you think you'll do it in the exam? The reality is you won't. Yeah, just make sure that's right. The reality is you won't because you're under stress. What do you default to? You default to your bad habits. So I might take out the negative on this one, just make it look cleaner. So I'll take it out front. And this is what I say to all of my students. I think my E12s are a little bit better because they are doing, their trials and stuff. Why you make silly mistakes quite often is because you haven't put in checks in place as you do the questions, right? You haven't figured out a way to check you're working on the fly. And it often stems from really bad homework habits. Like I can see where the student is going to make a ton of silly mistakes and those who will not. And quite often, obviously I get waved off saying, oh, don't worry, I'll do it in the real thing. But in the real thing, you're under stress. What do you default to? Your bad habits, right? So the really only way to tackle silly mistakes, I say that to all my students, it's not something you can address overnight. You can't just will yourself to not make silly mistakes. It doesn't work like that. You create good habits in your practice, in your homework. Treat it like, okay, if this was an exam, how would I write it, right? And I think the more you sort of do that in the practice, in the homework, where it doesn't matter, right? If you screw up, you screw up. It's not the end of the world. It's homework. But that's when you get good habits. And those good habits are going to be your default when you go into an exam. Yeah, so if you're one of those people who make tons of silly mistakes, like, you're like knocking yourself in the head. I know this stuff. Why did I just lose like a ton of marks? Yeah, give that a try. Yeah. So everything I'm talking about here, yes, you can stop here, but please don't, right? Practice and simplify all the way through because through that you're practicing factorization, term collection, knowing what to check for. Those things are important. And when you then take this question, having to solve it to something, this form is easier to work with than this form. All right, so that's my little tip on silly mistake there. All right, so I kind of jumped into an example with a product rule and a chain rule all in the one question. That was a little bit crazy. So let's just look at the individual rule applications and see how it works. So this is a chain rule application. You might not be able to see that yet, but if you think about what the bottom bit is, that's to the power of a half. So that's actually to the power of negative a half. Okay, so that's the chain rule. So y dash is equals to, you bring the power down, subtract the power by 1, multiply by the derivative of the inside. All right, so that's the first level. So that minus a half times minus 1 is positive, so I'll just write it as 5 on 2. All right, and you know me, I don't like my negative indices, so let's change it back. Now you can leave it like this, that's perfectly fine. Or alternatively, I just want to sort of talk about, well, 4 minus x, let me use a different color. 4 minus x to the power of 3 on 2 is 4 minus x 1.5, right? Indices law, yeah? 1 plus a half give you 3 on 2. So quite often you can also write it like that as well. And you see a lot of textbooks do that, and you're like, why isn't my answer matching? Well, you just probably haven't fully simplified it. That's all, it's the same thing. All right. Next one, quotient rule. Quotient rule, very important. Top is U, bottom is V. And the order matters. Is V U dash minus U V dash over V square. Okay? All right, so I'm going to do it slowly, just so that it's easier for you to follow. So U dash is negative 2, V dash is 3. All right, Y dash is VU dash minus UV dash over V square. Expand the top, simplify. And that is it. So let me just I've just been doing this without looking at my answers. Let me make sure I'm giving you the right stuff. Yep, that is correct. All right, so that's quotient rule. Next up, we have product rule. So I think we've seen something similar before, so we'll take this opportunity to look at product rule again in combination with the chain rule. So second time around, hopefully it makes more sense. U dash, but you know, looking through the question, these are all real exam questions. You can see the type of stuff that gets tested, right? So if you know these are the areas that your teacher is going to focus on, that's what you focus your study on. You don't need to study everything. You just need to know what is going to be examined and then work with that. Right, so the chain rule is bring the power down, subtract the power by 1 times the derivative of the inside, which is negative 5. And then this one's just 3. All right, so Y dash is VU dash plus UV dash. All right, so at this point it's correct, but I like things to be simplified. So if you look at these two terms, the lowest common multiple is 4 minus 5x to the power of 6. Okay, so then what's left is minus 35, 3x plus 7, and this one will be 3 times 4 minus 5x. Yeah, so you're dividing both terms by that. That's what you're doing. All right, let's continue. I thought that was 13 for a moment. Just making sure I got that right. All right, so that's 105. And then collect your like terms, so 105 minus 105 minus 15 minus 120 and minus 233. Now, with the double negative, you might take it out just to make it look neater. That's it. Alright, so that's another application of the product rule that's been fully simplified. Alright, this one's interesting. Can you guess what rule this is? Now, there's more than one way to approach this. I would treat this as x to the power 4 on x plus 1 to the power 4. Yeah, just put both top and bottom to the power 4. And now you have two options from here. You can treat that as quotient rule, or I'll just show you another variation. You can treat that as product rule. Yeah, if you change that bottom one to power of minus 4 instead. So I'm just taking a slightly unconventional path just to show you how you can manipulate this. All right, so that's true for any quotient rule actually. You can always turn it into a product rule just using the negative indices. But as you'll see, there might be a little bit more simplification on the back end as you attempt this. Okay, so I might just leave it like that. All right, so dy dx is just another notation for y dash. So vu dash plus uv dash. And then I'm just gonna change the negative indices back to positive indices. And then from here, I'm going to actually make it one fraction. So for those of you who went down the quotient rule path, you can actually compare this. All right, so first I'm going to times x plus 1 to the first one to make it one fraction. Expand. That's it. Oh, completely missed. All right, that's it. So that's an interesting one. So this is, I guess, quotient or product together with a chain rule. Alrighty. So the first section of this video, we looked at basically just differentiation, right? How to find the derivative, when is chain rule, product rule, quotient rule relevant, and how do you actually use those rules, right? The second section is more around the application. So I haven't really talked too much about, well, what is the derivative? The derivative gives us the gradient of the function. Specifically, it lets you find the gradient of the tangent at any specific point. So quite often, a lot of the application questions are around finding the tangent, finding the normal, and we'll also explore a little bit the concept of a gradient function and how you draw that as well. All right, so I might actually come back to this one because I realized this one's actually even harder than the next one. So I'm going to do the next one first, just so that you warmed up to how to find tangents and normals before we tackle the previous one. All right, so to find the equation of the normal, the first step is you need to find the derivative. Okay, so this guy, the 5 on the bottom is just a constant. So what you can do is just park that constant in front and just focus on differentiating what's on top. All right, so that's the derivative. All right, so the second thing is to find the gradient of the tangent at the point you're looking at. Okay, so the gradient of the tangent would be, you sub in the -1, and that's 2. Now, the thing is, tangents are normal. So tangent is a line that just touches, right? So let's say this is P, yeah? That's the tangent. Normal is a line that is perpendicular to the tangent at the same point. So to find the normal, it's always negative reciprocal of the gradient of the tangent, yeah, the relationship of perpendicular lines. So that would be the gradient of the tangent. And then the fourth step is to chuck all of that into the point gradient formula to get the actual equation of the line. Now, before we do that, we actually need the point because we only have half a point, right? We only have -1. So we need to find the y value at that point. So you just stick it in. So I'll just kind of mess with that on the side. So -3 times -1 squared. -1, -8. To be honest, just use your calculator. You don't have to do this manually like me. Alright, so you should get, make sure I got that right. Yes. -3. Okay. So then now we have the gradient point gradient formula. Multiply the 2 across. So -1 times x is -x, -1 times 1 is -1. Move everything to one side. Let's get that into general form. Alright, so the normal looks like that. So that's it. So this, if you wanted to find the tangent, by the way, just so that you know, you just use the gradient of the tangent and the same point and the same formula. That's it, just a different gradient. All right, so to summarize, first step, you need to find the derivative. Second step, find the gradient of the tangent specific to the point you're looking at. Third step, negative reciprocal gives you the gradient of the normal because they are perpendicular to each other. And then fourth step, point gradient formula. That is it. All right, so let's take a look at the previous question because I mentioned this one's a little bit tricky. All right, so we need to find what are the points that the tangent is parallel to this guy here. All right, so you need the derivative first, and the derivative of this is a little bit annoying because you need to get the quotient rule. All right, so top is u, bottom is v. All right, so vu dash minus uv dash v squared all right, so that's it. That wasn't too bad. All right, so now the gradient of this, let's get it into y equals mx plus b form. All right, so you can see that the gradient of this is 2, or -2, sorry. So if you want it to be parallel, yeah, you want y dash to equal to -2. You want the gradient of your tangent to equal to -2. So we need to solve the derivative to -2. Divide that -2 across. So that's 4. And then I'll continue up here. And then I'm not going to expand it, but instead I'm going to square root it. It's already factorized, right? Why waste more time to simplify? So root 4 is 2. So that's 10 and 6. All right. So now notice it says points, not the x coordinate. So you need to give points, which is x and y coordinate. All right. So just quickly working out when x is 10, y is 10 on 10 minus 8, 5. And when x is 6, y is 6 on 6 minus 8. So that's 6 on -2, -3. All right, so therefore, the points are 10, 5, and 6, -3. Alright, that is pretty much it. Wasn't too hard, but a little bit more advanced with this one. Alright, so now what we're going to do is tackle a question like this. So this is a fairly comprehensive question, multiple part question. And if I remember correctly, this is pretty much close to the end of the paper. So this kind of ropes in everything. All of your knowledge from functions to the derivative to finding tangent, and then the last one is an interesting one, and we'll see why that is the case. All right, so first, domain of the function. So domain in this case, you kind of look at the components, right? X squared itself doesn't have any restriction. If you think about x squared, it's all real x, right? I mean, I drew it badly, but it's defined for all real x. It's the second part. So remember, what's on the square root? You need to make sure it's always greater than or equal to 0, and that pretty much drives your domain. So that's pretty much your domain, all right? So therefore, domain is x has to be greater than or equal to 3 on 4. All right, so that's the first part. All right, the second part, the derivative. So let's start with the function itself. So this one's a little bit tricky, but at the same time, it's in the question, right? So if you go back to the question, if you couldn't get the second part, just go and do the third part. Just take the answer and do the third part. All right, so I'll change that to fractional indices. So product rule. U dash is 2x. V dash is bring the power down, subtract the power by 1 times the derivative of the inside. 4 on 2 is 2. Now what I also like to do is change that back into a fractional indices, sorry, a fraction like that. Okay, so f dash x is equal to vu dash minus uv dash over, oh, hold on, sorry. I was about to apply the product. Okay, quotient rule. I was about to apply the quotient rule, but I should be applying the product rule. Okay, so vu dash plus uv dash, that's it. Okay, so now we try to simplify this. Now you need to make this one fraction, right? Because the final thing is one single fraction. So you need to multiply this to the top and bottom. And now you can add it, yeah, because they have a common denominator. Expand the top. Alright, so that's 10x squared minus 6x, which factorizes into that. So at this point, you can pretty much just copy the answer or just factorize it. Alright, so that's pretty much it. So you see why practicing is important. Yeah, the question can force you to go down a particular path like this one. You have to show me this is the derivative. So you can't just leave a half done. All right, so that's the derivative done. Next, we want to find the tangent. So let me copy the derivative first, because tangent, remember, we need to look at the derivative for the gradient. Whoops, I copied the wrong thing. All right, so at that point, so you need to find P dash 3 first. All right, put that through into your calculator. It should come out at 24. All right, and then we stick in the information. So point gradient formula. Expand. I'm going to move the 27 across. And then simplify. This is a very, very steep line, gradient of 24. All right, but you kind of get the point, hopefully. So that's basically it. Last part. State the values of x where the tangents to fx are horizontal. So if you look at the derivative, right, horizontal means gradient is 0, flat. All right, so in other words, you need to solve f dash x to 0 if you want it to be horizontal. Now basically you're just solving the numerator to 0 because that's the only way for it to go to 0. But if you think about it, right, you try to solve this to 0, you multiply that across, it's going to go to 0, right? You can think of it like that as well. All right, so therefore x is equals to 0 or 3 on 5. Now, see if you can pick up the error here. So if I actually just quoted the answer, I get 0 marks. Now, this part is tricky for that reason. Let's go back to the original question and check out the domain here. The domain is meant to be x is greater than or equal to 3 on 4. What's wrong with our current answer? Neither of these are in the current domain. So it means that the graph doesn't even exist there, so it wouldn't make sense. Okay, so since these are outside of the domain, therefore, no, there's pretty much no answer, right? So, right, so that's all I wanted to say for this one. Tricky one. All right, finally, I just want to briefly touch on how to draw the gradient function. So this is an example of an exam question in this area. So generally speaking, right, so there are 3 types of considerations. So there are what we call stationary points, and that's when the derivative is 0. So like what we were looking at before, right, horizontal gradient. If you drew the tangent, it will be flat. Yeah, that's called stationary when the derivative is 0. There's another type called increasing. Increasing means it's sloping positively. I just realized I'm mirror, my reflection is mirror, so sloping positively, I'll just draw it. Yes, sloping positively, f dash x is greater than 0. Decreasing is sloping negatively, f dash x is less than 0. Okay, so when you're trying to draw the gradient functions, this is what I do. 2 core steps. So first, look at the stationary points. Boom, boom. Okay, those 2 points. And then around the stationary points, is it positively sloping or is it negatively sloping? So you can use a little plus to say, oh, that's positively sloping, that's negatively sloping, positively sloping. Okay, we'll draw it later. Let's answer the question first. It goes for what values of x is the derivative? So the gradient is negative. So we've already marked negative in that section. So x is in between -1 and 3, not inclusive, right? Because at -1 and 3, they're stationary. It's equal to 0. What happens as f dash x for large values of x? So you can see that now we're focused on gradient. F dash x is gradient. If you draw a tangent, right, to this point, you can see it's positively sloping, and then let's draw it to another point, and then another point. You can see that because it's approaching an asymptote, right? The line is getting flatter and flatter. So what does that mean? That means the gradient, it's approaching zero. Yeah, it's approaching flatter and flatter and flatter. It's approaching horizontal. All right, so we need to reflect this in our drawing. So now what I like to do when it comes to gradient function is I draw underneath it rather than on top of it, because I think it's just easier to see the relationships. Yeah, you always start with the stationary points because they are intercept points, because that's when your f dash x is equal to 0. Then you mark out your positive bits, negative bits, positive bits. So slope, we're talking about slope here. Positive means on the derivative function, it's positive as in above x. Okay, so you just make sure that bit is above x. So I'm just going to start drawing it. Above x. Negative means it's below x. Now you know you have to come back up to this point, right? So I'm just going to make it come back up to 3. And then positive again. At that. Now, actually what then happens, it comes back down and start approaching 0, because remember what we said, this gradient is getting closer and closer to 0, so you should be approaching 0. So approaching 0. Now, another little tip from me, inflection points. So it looks like on the diagram, these are inflection points. So that's when it changes from like a concave down to a concave up situation, or concave up to a concave down situation. Usually these equivalent to a point of inflection. These are point of inflection, and they basically are your turning points on the derivative function. All right, so to summarize, start with stationary points, f dash x. This is 0. They are intercepts. Positive means it's above the x-axis. Negative sloping means below the x-axis. Positive sloping, above the x-axis. And this one actually approaches 0 because the gradient is approaching 0. And inflection points is turning points on the derivative function. All right, so hopefully that helps. All right, so that's it for today. This is a revision module on introductory calculus. Some of the questions here are quite difficult, so hopefully you're pushing yourself, challenging yourself with these questions, picked up a few tricks and tips from me in this video. If you have any questions, comments, leave it down below. Feel free to also visit our website. So I've built at least 4 or 5 different revision modules now, so go check it out. There will be some extra practices uploaded there, so if you want to push yourself, practice a little bit more, feel free to download it and have a look at it yourself. Bye for now.